Alright, these are notes 8D. We're going to be looking at combinations and permutations today. So let's look at our first example. We have 3 students, Andy, Beth, and Kara, must arrange their desk in a row in their classroom. Your job is to figure out how many different arrangements they can make. We're going to make a list of all possible arrangements and then count how many arrangements are possible. Alright, so let's see, like I said, you might want to so take a moment and let's figure out how many different ways can we arrange Andy, Beth, and Kara. And we're going to list them as we go. Okay, so the order they're in now. So I'm going to say A, B, and C. So A, B, C is one order. Alright, let's do another order. We could switch Beth and Kara. So now we have A, C, B. Alright, let's put them back the way they started. Alright, we could switch Beth and Andy. So we have B, A, C. Alright, we could switch Kara and Andy. So now we have B, C, A. Alright, let's go back and let's put Kara first. Alright, so this choice would give us Kara, Andy, Beth. And then we could switch Beth and Andy. And we have Kara, Beth, Andy. So there's a list of all possible arrangements. So there are 6 possible arrangements. Alright, now doing a manipulation like this is all fine and good until we start getting a large number of choices. Then it's going to quickly get out of control. This is where we have math to the rescue. So we're going to look at this. This is a permutation. And the reason we know it's a permutation because order matters. If we change the order, we make a new choice. Alright, the way it looks makes a difference. Order matters. So this is called a permutation. We're going to take n objects taken r at a time. So let's look at this in permutation. Alright, here's the formula. Alright, this notation, that symbol, the exclamation point, doesn't mean we're excited about n. It means factorial. It means to count down. So for example, if I had 3 factorial, this means 3 times 2 times 1. Now we're going to stop counting at 1. We're not going to go down to 0 because when we multiply times 0, it's 0. So we're countdown stopping at 1. So 3 factorial is 6. Alright, so like 4 factorial would be 4 times 3 times 2 times 1, or 24. Alright, that's what factorial means. It means to count down to 1. Alright, so let's look at the formula for a permutation. So in our case, in our example, we had 3 people, 3 objects, and we want to place all 3 of them. So a permutation of 3, pick 3, or 3 permutation 3. Alright, the bigger number goes on top. Alright, I know these numbers are equal because we're taking all of them. Alright, but your n can never be smaller than your r. So n factorial, so in this case 3 factorial over 3 minus 3 factorial. So here's the formula. Alright, so this gives us 3 factorial over 0 factorial. Well, look at our note. 0 factorial is always 1. So this is 3 times 2 times 1 over 1, which gives us our 6 that we found by manipulation. Alright, so the formula is going to work here. And the formula, it works well too because for large number of choices, it's going to always give us the right answer. So our biggest job is going to be determining whether it's a permutation or we're going to show you later a combination. Now, if you want to know why 0 factorial is 1, here's a pattern. This pattern shows you. Take a moment and look at that. Here's one explanation of why 0 factorial is 1. So you can pause the video and look at that for a moment. Just remember, though, that 0 factorial is always equal to 1. Okay, moving on. All right, let's look at another example. Mr. Smith's class wants to elect a president, vice president, and treasurer. The names of these people are in in his class are the following. All right, so count how many people are in his class. We should get 19. So n equals 19. There's 19 people in his class. How many different slates of officers are possible? All right, the way we're going to treat this is that we're going to put everybody's name in a hat and we're going to pull out 3 names. The first person we pull out is the president, the second person we pull out is the vice president, and the third person we pull out is treasurer. So the order that we pull them out in is going to make us have a different president. So this is why this is a permutation. Order matters. Now in this case, we're not taking all 19 people, we're only picking 3 offices. So we're going to have 19 permutation 3, because I'm picking 3 offices. Alright, so let's set up our formula. N factorial, so 19 factorial over 19 minus 3 factorial. So this is going to give me 19 factorial over 16 factorial. Alright, now we can simplify this greatly. Now remember, 19 factorial is 19 all the way down to 1. And 16 factorial is going to be 16 all the way down to 1. So here, since this is multiplication, we can simplify this. And actually, what can we get rid of? Well, we can get rid of 16 factorial down, leaving us with 19 times 18 times 17. So when you multiply that out, that'll give us how many different slates of offices are possible. How many different ways can we select 3 members from our group of 19 to have our officers? And if you do that arithmetic, you're going to have 5,814 possible slates. Alright, so in order matters, you're going to use a permutation. You change the order, you change the president, that's a permutation. Because that's the hardest part about this. The arithmetic is not that difficult. It's deciding which one you're going to use, a combination or a permutation. Alright, let's look at another example. This is a permutation with repetition. So before we didn't have repetition because once we took somebody out, we weren't going to use them again. They couldn't be both the president and the vice president. Alright, let's look at this example. Suppose you need to choose a password that is 5 characters long and all characters must be taken from the first half of the English alphabet with repetition allowed. So that means we can use the same letter twice. How many possible passwords can you come up with? Alright, we've got 5 characters. So 1, 2, 3, 4, 5 characters. How many choices do you have for that first character? Alright, we want half of the alphabet. So that means we got 26 divided by 2, so there's 13 choices. Since we can do repetition, alright, I don't have to count down. I'm still going to have 13 choices for each one. Because I can repeat my letters if I want to. So another way of writing this is 13 to the 5th power. Alright, do that arithmetic. So that means we have 371,293 passwords possible. So it matters. So before, questions 1 and 2 with or without repetition, we didn't want to use the same person again, but with repetition it's going to change your math slightly. So the formula is not useful here because this is with repetition. Alright, let's try another question. Alright, this time, what are we asked to do? We want to form 2-person committees from our 4 students. We added a student. We added Dana into our list. So we have Andy, Beth, Kara, and Dana. How many different committees can we form? Alright, let's do this the long way first. How many different committees of 2 can we form? And let's list them. Alright, well we can have Andy. We can have Andy and Beth. We can have Andy and Kara. And we can have Andy and Dana. Alright, let's start with Beth. We can have Beth and Kara. We can have Beth and Dana. And alright, how about Beth and Andy? Beth and Andy, we already have Andy and Beth. That's the same group of 2 people. So we don't want to count them twice. So order here doesn't matter. So whether we pick Andy Beth or Beth Andy, we still have our same committee of 2 people. All right, let's start with Kara. What do we got? Well, we already have Kara Andy, so we're not going to use that again. And we already have Kara Beth. We're not going to use that group again. All right, so that means that only leaves us with Kara Dana. And here again, okay, so is that all of our choices? Well, we already have Dana Andy. We already have Dana Beth. And we only had Dana Kara. So that's all of our choices. So that means we can make 6 committees out of these 4 people. All right, so this would be an example of a combination. So let's look at the math behind that. All right, this is a combination. A combination tells you how many different committees are possible by using the following formula. All right, so here we don't want to count the repeats. All right, so order doesn't matter, so that means we're taking out the repeats, like Andy Beth and Beth Andy are the same group of 2 people. So we have an extra part of our formula here, an extra variable in our formula, this r factorial. What that does, it gets rid of those repeats in my formula. So let's use our formula to back up the math we just found, that 6 we just found. All right, so here's a combination. So I've got 4, and I'm going to choose 2 at a time. All right, formula says it's 4 factorial over my r, which is my 2 factorial, times the difference, 4 minus 2 factorial. All right, let's simplify this. So I've got 4 factorial over 2 factorial, 2 factorial. All right, let's think about simplifying this. 4 factorial means 4 times 3 times 2 times 1. 2 factorial is 2 times 1, and I've got another 2 times 1. All right, let's simplify. 2, 1, 2, 1, that's equal to 1. All right, let's multiply it back together. 3 times 4 is 12 over 2 times 1 is 2. Divide and we get 6. So see here, by our counting or by our combination formula, we're still getting our same 6. Here again, this is more of a direct way, and like I said, if our numbers get much larger than this, there's going to be a mess trying to count and not making sure you miss anybody. So the formula is definitely the way to go. All right, let's look at another example of a combination. Mr. Smith's class consists of 19 students. He wants to create a dress code committee. It's a committee composed of 3 students. So N is 19, my R is 3. All right, since this is a committee, I know this is going to be, I'm looking for keywords here. Since it's a committee, order is not going to matter, so that means I'm going to use a combination. So that's when you read these questions, you're going to say, does order matter? And that's going to determine whether you use a combination or a permutation. All right, so what have I got? I've got 19, I want a combination 3. I want 19 choose 3. So I've got 19 factorial over 3 factorial. All right, the difference, 19 minus 3 is 16 factorial. All right, let's think about simplifying this. So that 19 factorial means 19 all the way down to 1. I'm not going to write all of those. All right, I've got 3 factorial, which is 3 times 2 times 1. And I've got 16 factorial, which is 16 all the way down to 1. All right, so hopefully, like I said, you can see, starting to simplify this in your head. I can get rid of my 16 all the way down to 1. All right, so what does that give me left? All right, let's multiply the numerator back together. So that's, I'm going to get 19 times 18 times 17 all over 3 times 2 times 1. All right, multiply the numerator, which would give me 5,814 over my 6. Divide, and we're going to get 969 committees that we can make, size 3 out of 19 students. All right, so, all right, let's look at another one here. A student must read 3 of 8 books. All right, 3 of 8 books for English, and in math means multiplication. So when you see and, think multiplication. 2 of 7 books. So this is kind of a compound problem here. How many different selections can the student make? All right, now, we read 3 books. It doesn't matter what order we read those 3 books in. We're going to read the same 3 books. So that means order doesn't matter here. So this is going to be a combination. We're going to do 2 separate combinations. And because it's and, we're going to multiply those two answers together. All right, so I'm going to have 8 choose 3 and 7 choose 2. All right, let's do the formula twice. So I've got 8 factorial over 3 factorial times 5 factorial. Remember the difference, 8 minus 3 is 5, times 7 factorial over 2 factorial, and 7 minus 2 is 5. All right, let's simplify these. All right, think about what we have left here. 8 all the way down to 1, and I want to simplify my 8 factorial and my 5 factorial because it gets rid of the biggest chunk of my numbers. So I can cross out 5 factorial all the way down to 1. So that means in the numerator I'm left with 8, 7, 6, and my denominator I'm left with 3, 2, 1. All right, you can go ahead and do that math if you want to. That should give you 56. When you do that math. All right, here again, my 7 factorial and my 5 factorial. I can cancel out 5 all the way down to 1. So that leaves me with 7 times 6 in the numerator and 2 times 1 in the denominator. All right, do that math. 42 divided by 2 is 21. Now multiply 56 times 21 and you get 1,176 different selections. All right, so I have different selections. Okay, so like I said, it's all about being able to recognize whether you have a combination or a permutation. All right, last type of problem we're going to have, fundamental counting principle. 2 events can occur together in n times k ways. All right, so that means so let's look at our problem. A restaurant offers a special in which you can choose one of 3 appetizers. So I've got 3 appetizers, 7 entrees, and 5 desserts. How many different meals are available for this special? All right, so it's all about how many choices. You have 3 choices for appetizers and 7 choices for entrees and 5 choices for desserts. So we're just going to multiply these together. All right, assuming that we got to choose one of each. We got to take an appetizer, an entree, and a dessert, one of each. So when we multiply these together, there are 105 meals that we can make out of these different choices. So that's the fundamental counting principle. All right, so there's an example of all the different kinds of problems that you're going to have when you're going to practice. All right. Here are some words that will help you make a decision between a permutation and a combination. Remember, in permutation, order matters. You might want to write these down. All right. In a combination, order doesn't matter. All right. So permutation, anything about order. Arranging different officers, different prizes. All right, so if you're the first person chosen, you get a higher prize, and then the third person chosen, that would be a permutation. Combination keywords are committees or teams or groups, a selection. All right, so it's all about, like I said, the hardest part about this is deciding which one to use, a combination or a permutation. So let's make sure you understand, a permutation, AB and BA would be 2 choices. All right, and a combination, AB and BA is considered 1 choice. All right, order doesn't matter in a combination. How it looks matters in a permutation. So since they look different, AB and BA, that's 2 choices. All right, let's practice a couple, because like I said, just what you're going to have to do is be able to tell whether it's a permutation or a combination. So how many ways can we pick 3 different officers from a club of 20 members? All right, because I'm picking different officers, all right, what is that? What am I going to use, a combination or a permutation? Hopefully you said permutation. All right, so let's do the math here. This is going to be 20 pick 3. So it's 20 factorial over the difference, which is 17 factorial. All right, do that math. All right, so that means what? 17 down is going to divide out. So it leaves you with 20, 19, 18. Multiply that together and you're going to get 6,840. All right, let's read the second one. How many ways can we select a committee, keyword, of 3 people from a club of 20 members? Since it said committee, you should be thinking combination. Order doesn't matter. Same group 3 people, doesn't matter who's chosen first. They don't get anything special. All right, so this is going to be 20, choose 3. All right, different formula now, right? 20 factorial over 3 factorial times the difference, 17 factorial. Remember that 3 factorial in that formula is going to take out the repeats. All right, what do we got left? All right, let's do simplify the big numbers. So I'm going to get 20, 19, 18 in the numerator, and 3, 2, 1 in the denominator. So that's going to give me 6,840 divided by 6, which is 1,140 ways. So we have 1,140 different committees that we can of 3 out of 20 people. All right, please, like I said, if you have questions, write them down. Like I said, the hardest part about this, what gives people fits, is telling between a combination and a permutation, and we'll practice that in class.